Hey guys, it's Mr. Like again, and I'm back next to the Mississippi. Yesterday we learned a lot about the river and all the different states and all the different things that go along with the river, like headwaters and deltas and tributaries. Today I want to talk about why is the Mississippi right here? What actually made the Mississippi? Why does the Mississippi go all the way down the United States? How was it created? One of the first things that scientists do when they want to learn about something is they try to figure out all of the information that's already out there. A lot of times this involves reading things, reading articles, reading books, talking to people about things that are already happening. What I want you to do is I want you to open up the worksheet that goes along with this video and read a little bit about glaciers. Glaciers are large mounds of ice that move across different landscapes and actually can shape the land. These things grow, they melt, they do all these things that actually shapes the land. And it's one of the things that shaped Mississippi. Pause this video while you read, and when you're done, come back and we'll talk a lot about glaciers. Glaciers actually begin when you have more snowfall than you do have melting. If you have more snow falling on an area and it doesn't get to melt, it's actually going to get a bigger and bigger glacier. Now as the snow falls, snowflakes themselves are actually about 80% air. They're mostly air, so they're really light and really fluffy. But after they fall, they kind of melt a little bit, they evaporate up, they fall again, they do all this. It actually compresses down into little icy granules called firn. F-I-R-N. Firn. And that's only about 50% air. So it's really a lot more compact. Then what happens is over time, over years and years of this happening, more dust and more snow and more other things, water falls on top of these and compacts it down even more to become really dense. So it's only about 20% air. It's about 80% ice at that point. It becomes really hard ice. Years of compression gradually make the ice very, very dense. This compression forces out those tiny little air pockets between the crystals. When glacial ice becomes extremely dense, the ice absorbs all the other colors of the spectrum, making it look blue. When glacier ice is white, that usually means that there are many tiny air bubbles still in the ice. As the ice sheet thickens, the force of gravity causes it to move. Ice moves by changing shape or slipping and shifting along the cracks in the ice sheets. Like water, ice seeks the lowest levels and flows downhill. The ground beneath the glacier weakens due to the downward pressure of the ice and the constant water saturation. This ground breaks off and moves with the flow of ice. So, a glacier is a big block of ice that happens when you get more snowfall than you have melting. These glaciers move across the land as they flow downhill. They flow downhill because of a force that we already know about. It's the force of gravity. The force of gravity pulls everything downhill. So as these glaciers move, they take some of that land, some of the soil, some of the rocks, they take it with them along the way. And then when they melt, they might leave some of those giant rocks right there in the middle of nowhere. You may have seen some of these. If you're driving through Iowa, you can see on the side of the road, like on Interstate 80, some giant rocks that are right outside some of the cornfields. Those rocks were left there by glaciers hundreds of thousands of years ago. As the glaciers move, they actually reshape the land. This is called erosion. To erode away means to take little pieces away and change its shape. We see erosion lots of different places, and we're going to cover it later, but for our purposes, we know that the glaciers, as they move down the hill, they take those rocks and they erode. They take away little pieces of it and move them down. The path of the water and the ice and all of the glacier that moves down the land is called a current. Just like the current in a river. We talk about water moving in a river. Well, glaciers also have a current. It just takes them a lot longer because they move very, very slowly. In order to see how glaciers move across land, I've set up a model that we can kind of look at. On your worksheet, you have a couple of questions you can answer about this model, and we can kind of follow along. So what I have here is I have some modeling clay. This clay is the same thing as like Play-Doh or anything like that. You could use that if you wanted to try this at home. If not, you can just watch me do it. So this is modeling clay. I kind of pressed it down so it was kind of all stuck together. This is going to represent land that's really pretty like rock, like really hard, dense land. Then I made a glacier. I took some rocks and some dirt and some sand, all put it in this tub, then I put some water in it. I threw it in the fridge overnight so it froze, and now I have a glacier. So this is a good representation of what a glacier would be like. We have a lot of ice, and then we have a lot of other things that are stuck inside. So let's see what happens when I move this across this really hard, tough land. Let's see what goes on here. Ooh, she goes pretty slow. Glaciers move pretty slow. But as I move it across the land, what do we notice? Do you notice how there's some gouges now in the clay? Do you notice that some of the dirt was left over as I went through? What do you notice about the actual glacier now? Let's try this again with some sand and see if we get the same result. So we've already seen how a glacier can affect clay. That's really hard, compact, dense stone and rock. It actually gouges out pieces of that rock. What I have here today is actually a stream table filled with sand. So we can try the same idea with the loose soil. What happens to the soil on top and the dirt and all the other sands that are in the way of the glacier? So I'm going to take my glacier, I have my frozen glacier here, and I'm going to attempt to move it across this sand. What do you think's going to happen? Let's see what we can find out. As I move this thing across, the glacier comes down. It goes pretty slow. What do you notice? What do you see in my soil? Well, we're going to see these gouges taken definitely out of the soil. It doesn't quite leave as many of the things, the dirt and stuff from the glacier as it did before, but it does definitely make deeper gouges in the topsoil. Think about how this can be a way in which to gouge out or cut out the headwaters of the Mississippi so that we can get water flowing down this path. What do you suppose would happen if I just left this here and let it melt? So let's say it becomes summertime and things are going to start to melt. We want to make sure that we have a real glacial kind of a thing where we have an incline going down. We have a hill going down. Remember, gravity is going to pull this thing down the hill. So if I lift this thing up so that we have a hill, then we kind of just let this thing melt. So we can imagine that it's moved down the incline and now it's sitting and it's going to melt at the bottom. So let's move this thing down the incline, gouge out some stuff, and then it's going to hit here at the bottom of the hill. Maybe summertime starts and it starts to melt. I'm going to let this thing sit for a while and let's see what actually happened. Alright, let's take a look and see if we can figure out what happened. So as my glacier melted, the water from the ice actually started to move down the incline due to gravity. Water moves downhill just like a stream or a river. As it moved down, some of the lighter things that were in my glacier, like some of the small pieces of sand and some of the dirt, actually moved down with it. The heavier pieces of sand and the boulders actually didn't move much with the water. They just plopped down right where they ended up. We see this a lot with large boulders just sitting out in the middle of some of our fields in Iowa. They were left by glaciers thousands and thousands of years ago. This is called deposition. We are depositing different types of soils, different types of rocks and sand at the bottom of the hill as the glacier melts. We'll see more about how this stuff gets moved down the river next time when I see you.